Hey, here's a quick video, just a standard cell phone video. Sorry for the poor quality, but it's late. I just finished this up, so before I button it up, I wanted to capture it for anybody that might be having similar or the same trouble. This is on a Pulse tube amplifier. This is a 6v6 powered PM15H. This is the 15-watt version. It's a 6v6 push-pull. So at 70% dissipation, you're going to have about 77.5 watts per tube. So it has two 6v6s. And picked this up off Craigslist. The head was in mint condition. Got it from a guy who was just rolling it out. And then I realized that I kind of went and studied the brand a little bit more and saw that they had these 1x12 cabinets for a really amazing price. I mean, I couldn't even buy an empty cabinet for what they were unloading these for on Newark. So I bought the first cabinet and made some assessments. The speakers, the 12-inch Pulse speakers they put in it, to me, it's kind of like a PA driver. Now, that's not a bad thing. A lot of PA drivers have been used as guitar speakers, but you're going to get a big blooming bottom end. You're going to have kind of a relaxed mid-range and kind of a relaxed top end compared to a normal guitar speaker as well. So I ended up putting Eminence GB 128s, which is Eminence's version of a greenback in a 50-watt version. To me, the greenback or the GB128 is the most accurate clone in the Eminence line of a Celestion Vintage 30. I love Vintage 30s. Some people hate them. I love them. I know why people hate them, because they're kind of notchy and spiky in the upper mids sometimes, or in the top end. But that edge in the speaker, for me, I can't live without. As soon as I go to a more subdued speaker, it just doesn't have the edge and cut that I want. So I would rather use a Vintage 30 and then tune and EQ the amp to accommodate that. Because if it's not in the speaker, I can't get that edge, that breakup out of the amp. I really like that. But the GB128 from Eminence is a really great lower cost alternative, and this is meant to be a low cost amp, so that's what I used. The other thing I had to do on these speaker cabinets is change the grill cloth. The grill cloth was so thick it was like a quilt over. I mean, it was unbelievable. So I did change the grill cloth and put new piping in. And when I did that, as you can see, I actually had some custom actual Plexi logos made for it. I kept their brand name and stuff, but I wanted to kind of make it look kind of cool. I have the same thing on the head box here, as you can see. So anyway, it's my cute little amp, my cute little practice amp. However, after I did all those things to this amp, it started eating tubes, and then it died. It stopped working entirely. So that's why I'm making this video. If you've got one of these and it's stopped working, gave up the ghost or whatever, first thing I'll mention is this is the power board, and this is a chassis. It has a unique chassis. It's not a traditional chassis. It's got the top, which has 6 fasteners that hold it to the bottom of the chassis, and it's a solid state preamp with a tube power amp. This is a phase inverter, but you can clearly tell from all the surface mount resistors, it's basically a really nice solid state clean pre, like Roland like clean pre, and then whenever you hit the drive channel, the first drive channel, it's basically a TS9, so mid-humped tube screamer tone, which is okay. And then when you hit the ultra channel or whatever they call it, that's basically like a metal zone to me. I don't use those channels, I just use the clean, and this amp is worth it for the clean because I just, I have my own pedals that I like to run with it, and it sounds great. I really like it. But after I started liking it a lot, it died. So the first thing was it started eating tubes. Then it blew the high voltage fuse right there. So if you have an amp that's just died, they have there's 4 5x20 fuses on the main power board. And that was the problem. But once I replaced the fuse and brought it back up, I started studying the amp a little bit and realized that I was getting about 40 milliamps of plate current, which is way too high. So I checked the plate voltage. I was at about 370 volts. And so if you do the math, at 70% dissipation, my plate current should have been sitting at about 26 milliamps with a 14 watt tube. I mean, I'm running modern electro harmonics, 14 watt 6v6 GTs, not 12 watt tubes. So with that said, I tried to adjust the bias, and it didn't adjust. It didn't really even make a difference. Like, it went from 40.7 to 40.2, and I was way over. So after checking a bunch of other stuff, I realized I was going to have to modify the bias supply. I'm going to make a long story short here. I talked to a bunch of friends. I'm not a bias supply expert. I have some friends that are a little better at that stuff than me. So I called in some favors, and they gave me some tips, sent me some additional schematics. And one of the schematics one of my buddies sent me was for a Fender Blues Deluxe, which is a 6L6 amp, but it had a really very simple bias supply. It's basically a 25K pot in series with a 100K resistor, and then it's on a voltage divider with a 1.5K resistor, and that is how it generates the negative DC voltage to the grid, which is how you set your bias. I was unable to get, I only had about minus 20 DC on the grid, and I needed to be able to get that up to like 30 in order to get the plate current down to a reasonable level. So I knew I had to modify the bias. What I did was, this is very easy to identify in this amp. Hey, listen, if you don't know how to work on tube amps and you are not familiar with high voltages, don't do this. Have somebody else do it for you, because pin 3 in this amp is sitting at 370 volts, which will light you up and make you have a bad day. So don't reach into these amps if you don't know what you're doing. But if you do want to fix your amp, I can try to show you with this pencil. Here is a resistor, here is a resistor, and here is a diode. That diode is to apply the half-wave rectification to give you your negative bias for your grid. And then these two resistors make up the voltage divider, which this pot, which is not there anymore, used to be part of. So on the bottom, you've got 100K. The little blue resistor is 100K. And then the one you can see that I've replaced with a flame proof, that was a 30K. And so after a lot of tinkering, to more closely match the Blues Deluxe schematic, its final resting place on that is a 1K. So I went down from a 30K to a 1K on that. And then this little 5-volt trim pot that was here is basically worthless. It gave you like 1 volt range to try to dial in your bias. So as you can see, I wired it off board I ended up using a 50K pot here, which is in series with your 100K, and my experience is the higher that 100K goes, the more negative voltage you can generate as well. So wired that in. I even put a cute little knob on it that matches my knobs that I modified on here. And we have full success here. So I'll just show you real quick. I've been playing it all night. I'm at 25.27 milliamps of plate current. This voltmeter, I was checking my negative voltage at the grid, and I was pulling about negative 28 volts there, which is how I'm able to get about 25 milliamps for a 6v6 in general, a pretty reasonable bias. So let's just do the math real quick. I can tell you that because I've tested that amp, the plate voltage is sitting at about 370 volts. Sorry, got to get my computer up to use the calculator. So I'll just show it to you here. So if we, first of all, I'm using modern electro-harmonics tubes, which are the 6V6 GT. They are a 14-watt tube. You can pull the data sheet and check that out for yourself. I thought I had it sitting here, but oh, well, right behind it, basically that's the Fender bias supply I was studying that I used to modify my amp. So you can see the 25K in series with the 100K, and that's voltage divider with this 1.5K. And on mine, I ended up going with a 1K. But if we have a 14-watt tube, then we divide that by our plate voltage, which is 370 volts at the plate on this amp. Check yours. You know, I don't know what yours is going to be. So 37, almost 38 milliamps would be 100% dissipation. I was at 40 milliamps earlier, with a little bit higher plate voltage at that time. We don't want that. That's 100% dissipation on AB. That's a bad idea. You're gonna be damaging tubes and probably your amplifier. So then we say, okay, we want 70% dissipation, so we go times 0.7, and we come up with 26 milliamps would be 70%. So now after my modification, I'm actually sitting a little under 70%. I'm at 25.21. You know, I could adjust that up a little bit if I wanted. Here we go, turning my new little knob. There we go. I could push it up, but I'm going to run it a little bit cooler for right now to save my tubes. And we have success here. So fixed the fuse, fixed my bias, fixed the fact that I was able to pull more than like 20 volts at the negative 20 volts at the grid by modifying the bias supply in the little PM15. If you don't know anything about tube amps and you don't know anything about high voltage, take this to your tech. But you can even show them this video, give them a shortcut, because this is how I fixed mine. I'm so excited that I got this fixed because I love this little thing. It's cute. You know, I've got boatloads of 4x12s, you know, and racks of, you know, old 80 MP1s and pedal boards and stuff. But there's just something about a cute little quarter stack that sounds really good. I had in this amp until it died. So I'm glad I got it fixed without a lot of expense. Because when it first went out, of course, you know, you get worried that, oh boy, probably got a transformer that went poop or something like that. But it was a pretty simple fix, about a few bucks worth of parts, and quite a bit of time, and a little help from some friends who were offered me a little bit of guidance. So you know who you are. Hats off to you guys. Yeah, if you got a PM15 or maybe even the PM30, it looks like they might be using the same power board, 30 and 15, because I'm not sure if you can see. I'll try to zoom in there. On your tube socket, they say 6V6, 6L6. So they might be using the same board. One thing I'll tell you also is the silk screen on these printed circuit boards is amazing. I didn't have a schematic, and that was a bit of a problem. But they did so good silk screening these boards, and they tell you where your high voltage inputs are. They tell you where your bias supply inputs are. I mean, the bias supply input says 20 volts on it right there. Now that's 20 volts AC RMS. That's not your max voltage of 32. But it's very well laid out, and I dig these amps. I think they're pretty cool. So, all right. Hope that was helpful to you. See ya.